Wildcats, now we're going to take a look at dependent events. Dependent is the probability of the second event depends on the first event. So if you have a highlighter, I would highlight the word dependent. We're trying to find the probability of the second event, but it depends, that's where we get the word dependent, on the first event. Now this is without replacement. So we're going to find the probability of A, then B. This means we're finding the probability of A, just like we would before, but now we're going to find the probability of B following A, and we're still going to multiply the two. Make sure in the following examples that we simplify what we get. So let's take a look at this first one. It says a bag of marbles contains 5 red, 4 orange, 3 yellow, 8 pink, and 4 blue. Looking at this tells me what is in the bag. What is the probability of pulling a yellow marble and then a red marble if you draw a yellow marble on the first pull and do not replace the marble before drawing the second one? This means that I'm going to take out a marble and it's going to change how many marbles are left in the bag. Let's write this down. We're going to try to find the probability of yellow and then red. Finding the probability of yellow, then red. Remember, whenever we set up our probability, we're going to try to find what is favorable out of the total. So let's take a look. If I'm trying to figure out my probability of pulling yellow, I have 3 yellow marbles out of a total of 24 marbles. Once I take out a yellow marble, I'm going to be left with 23 marbles. Remember, I'm not replacing the yellow marble, so this changes the total that's in the bag. The next color I want to pull out is red. How many red options do I have? 5. So now we're going to take the probability of pulling a yellow, which was 3 out of 24. Say I pulled the yellow marble, leaving 23 marbles in the bag, and there's 5 red ones left over. Now I'm going to multiply the results. 3 times 5 is 15. And now we need to multiply 20 times 23. 24 times 23 is 552. Looking at this, I know I can simplify. My simplified version here is 5 over 184. If we were to write this as a percent, it would give us about 2.7%. This means that this is really unlikely that I'll be able to pull a yellow marble and then a red marble. Let's take a look at the next example. In a regular deck of cards, we understand that in a regular deck of cards, we have a total of 52 cards. What are the chances of drawing another heart if the first card you drew was the Queen of Hearts and you kept it? So again, we're trying to draw a heart after already pulling a heart. So let's set that up as a probability. The probability of a heart, then a heart. Feel free to write the word out, heart, if you want to. I just drew a picture of it. So when we set this up, I'm going to set it up as my heart over the total amount of hearts in the deck. Whenever we drew our first card, there were a total of 13 hearts in the deck. The deck contains 52 cards. What they told us in this problem is that I drew a Queen of Hearts and I keep it out of the deck. So now I've drawn a heart, and that means there's only 12 hearts left in the deck. And because I took the card out of the deck, instead of having a total of 52, I only have a total of 51. This is because I drew another heart. So now we're going to multiply 13 over 52 times 12 over 51. Let's multiply straight across. 13 times 12 gives me 156. Over 52 times 51 is 2,652. I notice the top and bottom are both even, so this tells me I can simplify. In your calculator, remember you can use the simplify button and it'll show an arrow down, which means you can keep simplifying. I can simplify this all the way down to a 1 out of 17 chance. I have a 1/17, or I have about a 5.9% chance of this happening. It's unlikely, but it is possible. Let's take a look at number 3. Number 3 says a drawer contains 10 black socks and 6 white socks. This is the contents of the drawer. If 2 socks are chosen at random, what is the probability of getting a pair of black socks? Now, when you hear a problem like this and we're talking about socks, it's usually because you're putting the socks on your feet. So I want you to think about when we grab 2 socks, one goes on your foot, and then you're trying to grab another sock and it's going to go on the other foot. So our probability is looking at a black sock, and then another black sock. Nothing is wrong with mismatched socks. I wear them all the time. So let's take a look. We want to get a black sock out of the total from the drawer. Looking at what we know, we have 6 black socks plus 6 white socks. That gives me a total of 16 socks in the drawer. Out of that total of 16, I know that 10 of them are black. If I pull a sock out of the drawer and I put the sock on my foot, that means there's only 15 socks left in the drawer. If one of them was black, that means there's only 9 black socks left. The chances of me getting a black sock, keeping it out, and then pulling another black sock, I'm going to know my chances by multiplying these two fractions. We would say 10 times 9 gives me 90. And then 16 times 15 gives me 240. Seeing that both these fractions end in a 0 tells me that I can simplify. And using your calculator, you can simplify this fraction down to 3/8. 3/8 is about 37.5%. It's unlikely, but it could still happen. Let's take a look at our last question. Number 4. Mason's Halloween candy is in a bucket. 12 of the 45 pieces of candy are chocolate. What is Mason's probability of picking 2 pieces of chocolate if he ate the first one he got? I don't blame you, Mason. So we're going to look at the probability of getting chocolate and then chocolate. Now, the difference between these problems and the problems we did above is we're not replacing them. This is without replacement. In this case, Mason has eaten the chocolate. So, looking for important information, 12 of the 45 pieces of candy are chocolate. Looking at this, it tells me how to set it up. We're going to do 12 out of 45. Now, because he's taking a piece out of the bucket, that means there's only going to be 44 pieces left over. We're hoping that one of those pieces was actually chocolate, so 12 minus one of the pieces leaves me with 11. And now we're going to multiply straight across. If you will, do 12 times 11, and that gives us 132. And then you're going to multiply 45 times 44, and that gives us 1,980. We want to make sure to always simplify our answer, and when you do so, that gives us a 1 out of 15 chance. 1 out of 15 chance leaves us with about 16 2/3% chance of this happening. Great job, Wildcats. Continue on for some independent practice.